All right then, so we're just about now to the point where we can start doing some real stoichiometry. Okay? All right, so let me give you a problem that has to do with real stoichiometry. Okay? Please write this down as I write it.
Where's the hole puncher?
Right up there. Yep. All right. So we're starting off with a mass of NO. Okay? A mass of NO. And when we finish the calculation, we want to end up with a mass of O2. Okay? Question is, how do we get from here to there? Well, you can't do a direct conversion between mass of NO and mass of O2. You have to go through Moleville. Okay? So what we're going to have to do here is convert the mass of NO. Going to convert it first to moles of NO. Then from moles of NO, we're going to convert to moles of O2. And then from moles of O2, we're going to convert to the mass of O2. So all these things we've been learning over the past week about converting from mass to moles and moles to mass, and the stuff you were supposed to study over the weekend about molar ratios, we're going to use all of that for this calculation. Okay? So what's our starting amount? 2.50 grams of NO. Okay? And what do we do with the starting amount? Put it over 1. and multiply it by something to get, so we got to go to moles of NO. Okay? How do we convert from grams to moles? What do we do to go from mass to moles?
Add on the little, molar mass.
You got to calculate the molar mass, not Avogadro's number. This is the molar mass. Got to add all the atomic masses of all the elements in the formula. So nitrogen is 14.0067. That's its atomic mass. Oxygen has an atomic mass of, well, we use oxygen a lot. It should be fairly easy to memorize it. We use it so much. Okay. So 14.0067 plus 15.9994, and I get 30.0061. Say what now? 30.0061 is what I got.
Oh, I get to.
Okay. Okay. Now there's no empty slots to the right over here, so there's no rounding off that we have to do. So this then is the grams of NO, and that equals 1 mole of NO. What now? Okay, for the conversion unit then, we need to take the side of the equality statement that matches our starting amount and put it on the bottom of the conversion factor, the conversion unit. This? Just 1. We put that as a placekeeper down here. Okay? So what do we put on the bottom?
30.061 grams of NO.
And what goes on the top of our fraction?
1 mole of NO.
Okay. So we've successfully gone from mass to moles. Okay? We can cancel. Okay, and when we do the math, we'll have this answer. Okay? Whatever this answer is, that becomes a new starting amount that goes over 1. So whatever answer we come up with here, that becomes our new starting amount. And it'll be some kind of moles of NO. Then we're going to find the molar ratio we need. Well, we already balanced the equation in that quiz. 2.50 divided by 30.0061. What? Hang on a minute. We don't want to do that yet. Okay. All right. So from the balanced equation, moles of NO in the balanced equation is 2. And moles of O2, which is what we're trying to find, how many moles of those do we have in the balanced equation? What? Look. How many moles of O2 do we have? 1. The coefficient is 1. So that's 1 mole of O2. Okay? Then you'll have another answer here. That'll get us to moles of O2. Now we've got to take that answer, and it's got to be a new starting amount, which is moles of O2. And so whatever moles of O2 you get goes over 1, and you have to have a new conversion unit to go from moles to mass. So you got to calculate what? go from moles to mass, what do you have to calculate? Molar mass. Again, but this time for O2.
Oh.
So you got to add oxygen's atomic mass twice, set it equal to grams, or set it that it's grams of O2 equals 1 mole of O2. All right, everybody just stop what they're doing. Stop. James, stop. Everybody sit still a minute. Too many of you are so worried about packing up your book bag to get out of here when the bell rings, you're not paying attention to this. Okay? This now is a homework problem for you to finish. I just told you how to do it.
Okay.
Okay?